Hello everybody. I have a question for you. How can we find the volume of a cone? Now, how do we even start on this problem? A cone is weird. It's slanted, not straight. Unlike a cylinder, we can get a cylinder's volume easily. We just multiply the base with the height. If a cone was so straight, this wouldn't even be a video. But wait, maybe it can. Perhaps you've seen the proof for the area of a circle. You can take a circle and cut it up into many slices, such that each slice is of an equal arc length, and then you rearrange them to form a kind of parallelogram. You continue this process on and on for more and more slices until you get a rectangle. You then calculate the area of this rectangle and find the area of the circle. The point we want to take away is the cutting up part. Maybe we can cut up our cone into cylinders. Now, what happened there? Let's look at a cross section of the cone. We can describe each shape in that series as a number of vertical cylinders of the same height stacked upon each other so that they share their base with a horizontal section of a cone and their height adds up to be that of the cone. We should now try to gather some more information about this process. We can do that by looking at a vertical cross section of the cone and the shape in the series together sliced at the base diameter. Let's introduce some nomenclature. Let h be the height of the cone. Let r be the base radius of the cone. Let n be the number of divisions or number of cylinders in a shape of the series. First, the most obvious piece of information. Since the height of each cylinder is equal, each height will be equal to h over n. Next, let's draw the base diameter of each cylinder and also draw perpendiculars from these corners. It can be clearly seen that these values, let them be a, are equal and can be proved using AAS congruency of the triangles they are part of. Let this red line represent the base radius of each cylinder. So, for the first cylinder, it is r. For the second cylinder, it is r minus a. For the third cylinder, it is r minus 2a, and so on. Therefore, each radius is decreased by a succeeding amount of a's. Next, let's label the height and the base radius of the cone. Since there is one a for a particular side of each cylinder, n a's add up to be equal to r. Hence, the value of a is r over n. We can finally calculate the volume of the individual cylinders. The volume of the first cylinder is its height times pi r squared. The volume of the second cylinder is its height times pi r minus a squared. Remember, the radius of each cylinder is decreased by a as we go up. The volume of the third cylinder is its height times pi r minus 2a squared. Here we only have 3 cylinders, but there can and must be many more cylinders to get the volume of the cone. Since we know the value of a, let's substitute that in. We can also factor out the r and then distribute the squares. Now let's add up all the individual volumes of the cylinders to get the total volume. In this summation, there will be n terms as we have n cylinders. So, when we factor out the h pi r square over n, there will be n terms inside the brackets. Actually, let's put the 1 over n factor into the brackets. It will now be easier to ignore the h pi r square and just look at the terms in the brackets. Let's even ignore the 1 over n. Much better. Our job now will be to try and open up the squared terms. If you look at each squared term carefully, you can see that they are in the form 1 minus x over n whole squared, where x is a natural number that increases for each succeeding term. Opening it up, it will be equal to 1 minus 2x over n plus x square over n square. Great! Let's apply this in our original expression. There were n minus 1 squared terms, so there will be n ones, as we have to include the 1 at the start. There will be n minus 1 negative 2x over n terms, and there will be n minus 1 x square over n squared terms. The ones will clearly add up to n, and from the negative 2x over n's, we can factor out the negative 2 over n, and from the x square over n squares, we can factor out the 1 over n square. We can now see two series. First is the 1 plus 2 plus 3 plus dot dot dot. Since there are n minus 1 terms, we can substitute the formula and it comes out to be n minus 1 times n over 2. Second is the 1 square plus 2 square plus 3 square plus dot dot dot. We also have a formula for that, and we can substitute n minus 1 to get n minus 1 times n times 2n minus 1 all over 6. Now we just have to simplify and also return the 1 over n factor to get this expression. If you recall the original series, n keeps getting bigger and bigger until the shape reaches that of a cone. Our goal was to find the volume of a cone. So in order to do that, we need to take the limit as n approaches infinity. Here, as n gets bigger and bigger, the 1 over 2n and 1 over 6n square completely vanishes. In other words, they approach 0. So we can compute the limit to be 1/3. Wow! The entire huge expression dissolved down to just this? We now just have to go back to the first expression, the total volume of the shape. We then take the limit as n approaches infinity to get that the volume of the cone is 1/3 h pi r squared. And there you have it. The volume of a cone is 1/3 h pi r squared. In fact, this method of slicing shapes up does not just apply to the cone, but can also be used for a sphere. Why don't you try it out and tell me in the comments? So, till then,